So we talked about complex numbers, complex number set being consisted of a real part, let's call it A, plus an imaginary part that we denote with J in front of that. We talked about that you can add complex numbers together by adding the real and the imaginary part separately. Of course, you can also multiply them. So if we have one number, complex number called 3 plus J2, and another one, set 2, called 2 plus 4. J, you shouldn't make it too complex. So set 1 times set 2 set 3 plus J2 times 2 plus 4J. And now you need to take the one part and multiply that into the other. 3 times 4 plus 4J and plus J2, 2 plus 4J. And then you continue to go in here. So 3 times 2, that's 6. 3 times 4, that's 12. J plus 2 times 4, 4J plus 2 times 4, 8J squared. Here comes the remember again, J squared, that is equal to minus 1. So this whole thing becomes minus 8 here, and real. Here we have 6, and these two can go together also, plus 16J. So if we put that together, we get 6 minus 8 minus 2 plus 16J. Yeah, as you see, this is not very difficult, but you need to keep your tongue a little bit in the right place, not to lose track of anything. But since complex plane and this rotating vector is so darn useful to represent signals, and sometimes we want to multiply signals like that, fortunately there is another even smarter way to represent this. So instead of the rectangular form, I said that we can also look at the complex number with the real part and the imaginary part as a vector. The vector has a length and an angle. Now the real clever part of this is that we have something called a complex exponential. A complex exponential, you can look at the same thing with as e to the power of j angle with the amplitude in front. So set has a rectangular representation or a complex exponential representation. And these are the same thing. They're related to the same thing. They're just two different views of them. Now the real benefit of this is that if you have two exponentials, complex exponentials, and you want to multiply them, it's super easy. So let's say we have one called 2 times e to the power of minus 2, and another one that is 4 times e to the power of minus, to the power of j3. Multiplying set 1 times set 2, that's 2e j2 times 4e j3. And if you remember how to deal with this, you multiply the amplitudes in front. So 2 times 4, e to the power of j, and then you just add the angles. 2 plus 3. So here we have 8, e to the power of j5. And that's it. So instead of going through this very cumbersome j to the power of j squared minus 1, is it real, is it not real? You have something that is very easily and compact, representing both the real and the imaginary part in one, as the amplitude and as the angle. And that's going to be really useful when we look at more how to treat signals.